So when it comes to your double angles, like I said earlier, they are on your formula sheet. You don't need to know them off by heart. They are given to you. They are there. So a double angle is essentially when you are multiplying an angle by 2. I don't quite know how else to explain that. If you double something, you times it by 2. So for example, if we had the angle sine of 2 times 30, we're potentially looking at a double angle of 30, so we're looking at sine of 60. Essentially, what you need to take away from the double angle idea is that an angle can be broken down into 2 equal halves, hence a double angle. The double angle formula that we use is only one identity that we use for sine. So the sine double angle, so you can see there the double angle is represented by the 2a. The sine double angle is equal to 2 times sine A times cos A. So basically, if you had the angle of sine 60, it would be 2 times sine 30 cos 30, half of that double angle. Cos has 3 versions of the double angle that we need to be able to work with. Obviously, there's some situations where it makes no difference which one you work with. Obviously, there's some situations like when we're proving identities, we will need to look carefully, at what you're trying to prove in order to decide which identity we should use. And we're going to do questions like this, so don't stress. But there are 3 options available to you. So it's either cos squared of the angle minus sine squared of the angle, 2 cos squared of the angle minus 1, or 1 minus 2 sine squared of the angle. Any of those 3 will work for a cos double angle. It all sort of goes back to that square or Pythagoras identity that we worked with way back in like grade 10. But those are the double angle formulae that you need to know when it comes to trig in grade 12. So again, they're on your formula sheet. You don't need to learn them off by heart. We do need to, however, apply them. Now, double angles, like I said, the basic idea that you need to be able to work with is the fact that any angle can be halved. So any angle can be the double of something. 60 is double angle of 30. 80 is double angle 40. Any angle that we're working with, we can convert it to a double angle if we need to. Now, again, we will only obviously use these when the context requires us to do so. And we're going to start having a look at those types of questions now. So remember, guys, basics today, and we're going to build it up when we get to the more complex stuff on Monday. And we're going to start essentially applying it to things like identities or proving identities, simplifying expressions, solving equations. All right. So let's just start off slow. All we want to do here is we want to expand the identities. So, got a bit enthusiastic there. Going to leave our identities up for us. We want to expand. So what we have is sine of 4a. Now remember I said to you, any angle can be broken down as a double angle. I could write this as sine of 2 times 2a. That is the double angle or double of angle 2a. So we need to sort of almost go back to what the double angle would look like in order to expand. We can see what the sine identity is for our double angle. You don't really need to do much more than look at your formula sheet. And so sine of your double angle is equal to 2 times sine A times cos A. Now, it's really useful for us to be able to visualize, like I say, that any angle can be a double angle, because now what we can see through this visualization is that we've got sine of 2a. So this whole bracket here represents the angle that I am doubling. That therefore means that I can expand the sine of angle 4a to be 2 of sine 2a times cos of 2a. So I'm able to take the original double angle that I have and expand it according to my double angle identity. Now, again, right now, this is just the basic stuff. The likelihood of you being asked this in like a final exam or during exam is pretty much 0. You're going to be asked it in the context of a question. That the ability for you to be able to use your identity and either expand, and either expand or write it as a single term with that double angle formula applied is really important, because when you now start getting to expressions, being able to do both of those things is really important. So if we have a look at question 2, we've got cos of angle x. Now again, just because there's not a coefficient in front of x doesn't mean that my angle can't be a double angle. If you imagine this, this would be cos of 2 times a half x. Now why 2 times a half x? Well, 2 times a half x, 2 times a half is 1 x, so just x, taking me back to the angle x I have. So even when you're working with a single variable, again, any angle can be a double angle, you just need to halve it. So what we have here is our cos of 2a, if you think of it in terms of the identity you're given on your formula sheet. And now remember, cos of 2a, you've got a whole bunch of different options that you can apply your double angle to. So your first option could be the cos squared a minus sine squared a. Your second option could be the 2 cos, currently that's cos squared a minus 1. And your third option could be 1 minus 2 sine squared a. Now again, grade 12s, I don't care which one you use. So in this case, you would pick one and you would stick with it, and that's it. You don't have to give me all three. When it comes to the exam type questions that we're going to start looking at on Monday, you will need to be able to look at the question, or you will need to be able to look at the context you're given and decide which is the most appropriate. So when you're proving an identity, for example, you're going to have to look and see what you're trying to prove one side is equal to in order to determine which of these identities that you're going to use. And again, we'll have that conversation when we get to those types of questions. But it's important that you know that there's 3 choices and you have to make the best choice based on the given question that you're working with. Now, like I said here, it makes no difference which one you choose to work with. All of them are fine, because all I've asked you to do is expand. Essentially, by choosing any one of these 3, you've expanded. So either you're going to have cos squared of a half x. Now remember, it's a half x because that was what my original angle was before I doubled it, minus sine squared a half x. Or you're going to have 1 minus 2 sine squared a half x. Or you're going to have 2 cos squared a half x minus 1. Any one of these 3, given the context of this question, I've just asked you to expand, nothing more than that, would be absolutely fine. Okay, you've chosen the identity that applies to your cos double angle. You've expanded, no issues. So when we get to something with a numeric example, a numeric angle, such as question C, sine 50, again, nothing changes. Visualize this as what the angle you would need to be working with is doubled, because remember, this is the double angle we're working with. So this would be sine of 2 times 25, because double 25 gives me the double angle of 50. It's a sine ratio, so there's only one option for sine. That would be 2 sine of your original angle A, so 25 degrees, times cos of 25 degrees. So all this is, guys, is looking at your formula sheet and applying those compound angle formulae. There is nothing more to it than that when we're expanding. All right, so let's take a quick screenshot of these 3, and then you're going to try some by yourselves. And again, yes, this is basic. This is not supposed to be super tricky yet, but it's because if you can't do the basics, you're going to really struggle when it gets to the more complex questions. So we need to practice the stuff now, especially because this is brand new, so that we can apply it later. And especially double angles, there's a few little curveballs we like to throw at you, and you need to be able to deal with them. And remember, guys, if you have questions, please just ask as I go along. Right, however, you should have got screenshots, and you are going to try these 2 here for me. Let's just type it here. So you've got two questions here. Cos of 80 and sine of 6p. I don't know why it's gonna, okay, I think that's good enough. So expand these two, same thing as what we were doing. Visualize, I've given you the double angles. You now need to take the identity and take them back to the non-double angle simplified form. And I give you, I don't think this will take too long, so 2 or 3 minutes, and then we'll double check. Okay, guys, let's have a look. Hopefully we've got that. Remember, just take screenshots if not, but we're imagining our double angle. So these are both double angles that we've been given, which means that cos 80 we could write as cos of 2 times 40. I actually used this example earlier. And sine of 6p we could write as sine of 2 times 3p. We could break up those double angles for ourselves. Once we know what we're working with, we can apply our identity like I've done here. So exactly like I say, cos of 80 can be written as cos of 2 times 40, which means that you're working with an angle A of 40 that was then doubled. And so you can apply your identity. Cos, remember, there's 3 options. Because we're not trying to solve an equation or simplify or prove an identity here, it's not really important which one we choose. So any of those 3 are absolutely fine. You don't have to write all 3. One of them is fine. For the sine 6p, as we've discussed, that would be broken down into a single angle of 3p, which has been doubled to give us 6p. Sine, there's only one identity, so it's 2 sine 3p times cos 3p. Right, I'll wait there in case you need to take a screenshot. Otherwise, let's have a look at our second example. Okay. Okay, so our second example here, all we want to do is we want to go from our expanded form, writing it back as a single trig ratio. So we've got our formulas here on the side. I'm going to do this throughout this lesson just so we can get used to them. From sort of Wednesday onwards, I expect you to have a formula sheet in front of you or for you to have a note somewhere with these identities. Remember, I have put a formula sheet on Google Classroom for you guys. Okay, so write the following as a single trig ratio. Obviously, the first thing that we do just want to double check is the fact that the angles do match up. So I've got a cos 3 theta, a sine 3 theta, and a cos 3 theta. Those angles match up, which means we can take it back to a double angle. Now, because it's a 2 sine 3 theta cos 3 theta, we're working with our sine identity, which says sine of 2a is equal to 2 sine a times cos a. So remember, what we're wanting to now write down is the double angle. And so that means we need to ensure that we double the angle that we were originally given. Okay, so that would require us to now say sine of double the angle given, which was 3 theta, meaning that we're actually working with sine of 6 theta in this question. Now, you don't have to show the step where you show the double angle. Obviously, if you're more comfortable with it, absolutely. I'm more just showing you that to remind you that what we're doing when we simplify it into one trig ratio is we're writing it with that double angle. And so we need to bear in mind that we are actually doubling the angle we were given. Right, so question B, we've got 1 minus 2 sine squared theta. If we have a look, this matches up with a cos double angle. So cos of 2a is equal to 1 minus 2 sine squared a. That's the identity we're working with. So we're going to simplify this to a single cos double angle. Right, remember we're going to the double angle, which means that the angle we were given, we need to double. So this means we're working with cos of 2 theta. I took the angle that I was working with, theta, and I doubled it because we want to get to the double angle, the simplified expression with our double angle. Right, when we get to question C, we've got sine squared theta minus cos squared theta. Now remember that the identity for cos 2a, if we go back up to identities in case we've forgotten, is cos squared a minus sine squared a. If you have a look at what you've been given, that is not the case. What we have been given is sine squared minus cos squared, not cos squared minus sine squared. So this is what I'm saying, not we like to trick you, but we do sometimes throw a curveball. You need to be very mindful of the fact that it is cos minus sine, not sine minus cos. Order of subtraction is very important. Ooh, sorry, guys. Order of subtraction is very important. 3 minus 2 does not give you the same answer as 2 minus 3. They're not the same thing. Only addition order is not important. 3 plus 2 is the same as 2 plus 3. But subtraction, the order is very important. So the problem is that this order is not correct in order for me to apply my identity. But remember, anytime you are working with the difference of two terms, you can swap those terms. We swap those terms. If you think back to your algebra that you did in like grade 9, grade 10, when you did factorization, you can switch terms by multiplying by -1. So if you multiply by -1 or take -1 out as a common factor, you are able to switch the order of your terms to now be cos squared theta minus sine squared theta. If you multiply that negative back in, you end up with the original anyway, so it's fine. There's nothing wrong with that. You're just manipulating your expression to get what you want. Now that this expression does actually match up with the identity we're working with, now we can apply our double angle. So this is a cos double angle, so minus cos of double the angle given, theta. And so we have negative cos 2 theta. So always double check that the expression that you're working with does match up with the identity that you have on your formula sheet or that you know. And if it doesn't, some manipulation will have to occur. Obviously, it depends on the question, what that manipulation might be. In this case, because it was just an order of terms that we had an issue with, the manipulation involved multiplying by -1. You can do that. There's nothing wrong with that. We do that all the time when we factorize algebraic expressions when the order is wrong. I call it a switcheroo. I don't know what other teachers call it, but I call it a switcheroo. You can switch terms. There's nothing wrong with that. But the way to switch terms that are in the wrong wrong order when you are subtracting is to multiply by a -1 or factorize out a -1. Okay, so these are the things we need to look out for when we're looking at these types of questions. I said this earlier, we do like to throw a little curveball every now and then. We need to be mindful. There's another curveball that we'll see a bit later on, but let's screenshot this, and then you're going to try some by yourself. Right. Alrighty. And again, grade 12s, if you have questions, just ask. Again, I know we're just doing the basics right now. We need the basics to do the hard stuff. All right. So this is the question that you're having a look at. Just going to move this here so you can actually see what the formulas are. So I want both of these written as a single trig ratio. We've got cos squared 2 theta minus sine squared 2 theta, and then 2 sine of a over 2 times cos a over 2. So think about the fact that you're trying to write it as a single trig ratio with a double angle, and think about what that will mean in terms of your identities that you can use and what angle you're working with. Right, 3 minutes, and then we'll have a look. Okay, let's have a look. So if we have a look at the first one, remember that these are the single angles, for lack of a better description. So we need to now write it as a single double angle term. So the cos squared minus sine squared, that was the right order. There was an issue like there was the last time. Yo, guys, I'm sorry. I'm so tired. I don't know why. That was absolutely fine. No problem. So what we now have to do is double the angle that we were working with the cos ratio, because it was the cos identity. So that would give us cos of 4 theta. Now we just need to be careful in question B. It's a over 2, which means if we double a half a, we're just getting angle A. Because it's a sine, we're working with the sine double angle, and so we have sine A. I'll come back to this in a second. This was very similar to what we had in this example B up here, where we had cos x and we wanted to expand it. We then needed to go back to what the original angle would be that we would have to double, and it's half. So whenever you have a situation like that, don't stress about the fraction. There's nothing wrong with having a fraction. Just think about what it means in terms of your double angle. Okay, so take a screenshot and then we'll have a look at our next example. Okay, so remember, anytime you're working it with trig, you have to be comfortable with your special angles. It's just something you have to be able to do. As I've said to you before, if you don't know the special angles off by heart, it's really not the end of the world. Just use your calculator. Just make sure you are showing all of your working out. So this is essentially what we have going on here now in example 3. Determine the value of the following without the use of a calculator. Okay, so once again, let me just move this because it makes no sense for it to be all the way here where it's not actually useful to anyone. Alrighty. So we can clearly see we've got sine 215 times cos 15, which is clearly a sine double angle situation. So that's what I'm going to work with. The sine of the double angle, cool, means that 2 sine 15 cos 15 becomes sine of double that original angle 15. So what I'm actually working with here is sine 30. Now the giveaway that I'm going to be working with special angles is this without the use of a calculator. Whenever we say that in trig, okay, apparently we're going to have an arrow. Whenever we say that in trig, it means that you're likely going to have special angles that you need to deal with, particularly when the example or the question has numbers in it. So obviously you're not going to use a calculator if you've got thetas and you're just applying reduction formulas, obviously. But when you get to things like this where there's numbers and we say without the use of a calculator, special angles, that's what you're aiming for. Right, now we've done that, which is great, but we want the value of this. So we now need to go and figure out what sine 30 is. Now, just for the sake of reminding you, remember you do have your special angle triangles. Terrible triangle that I've drawn here, but we're just going to pretend that's fine. You've got your 30, 60, 90 triangle. I'll draw the other one in a second. This would be 2, 1, 3. Obviously, it depends where you put the 60 and the 30. Doesn't really matter. Let's see if this, there we go. And then you've got your 45-degree triangle, which is root 2 to root 2. All right, so we're looking for sine 30, opposite over hypotenuse. This is a half. If you didn't remember the triangles, if you didn't know that, type it in on your calculator. There's nothing wrong with doing that. It's absolutely fine. Show all you're working out. That's all you really need to remember. Okay, if we have a look at B, we've got cos squared 15 minus sine squared 15. That matches up perfectly with one of our cos double angle formulae. So this is going to be cos of double the angle given, which is 15. So what we're working with here is cos 30. We've got the triangle up there. We can use that. Alternatively, just punch it in on your calculator. Square root 3 over 2. So never, yeah, English words there. Whenever we say without the use of a calculator, just use your calculator to double check. All right, so I'm just going to stop here, take a screenshot, because the next, next two examples are slightly more complex. This is where we do like to throw a curveball at you guys, so it's just something that we need to be mindful of. So let's take our screenshots here, and then let's have a look at the next two examples. Alrighty, so the next example that we've been given is 4 sine 105 times cos 105. Now, what I want you guys to remember is that this is a sine cos situation. There's no squares, so it means it's a sine double angle identity. And remember that your sine double angle identity is 2 sine A cos A. So we love to throw this example here at you guys. The problem that I have is that my coefficient to the sine 105 cos 105 is not 2, it's 4. Now, there is, once again, nothing wrong with that. It just means you need to manipulate. And this is one we often expect you to be able to manipulate. So there is nothing wrong with me having the form there, 4 there. I'm just expecting you to be able to manipulate this expression to look like 2 times sine A times cos A. So if we now break the 4 up into a 2, or take the 2 out as a common factor, you would have 2 times 2 sine 105 times cos 105. Okay, cool. This is now matching up to my identity. So this is now what I want. What we now need to bear in mind is that we have this coefficient of 2 here. It's just a coefficient. Nothing wrong with that, nothing I need to stress about, but it is there. Within this bracket, I am now able to apply my sine double angle identity. So in this purple bubble here. Leave the coefficient of 2. There's nothing wrong with it. I've dealt with it. It is there. And now we can write the situation as sine of double the angle 105. Sorry, guys. So what we have here is 2 sine, and double 105 is 210 degrees. Now, lots of different ways that you can deal with this. As I've said to you before, there is nothing wrong with you doing it differently to the way I'm about to do it, or the way your friend does it, or the way your teacher does it. As long as you are applying the knowledge that you have of trig correctly, go for it. Do what you want to do. So you could use a 270 reduction. As I've told you before, I stay away, a 270 reduction, a 270 co-ratio. As I've said to you before, I stay away from 270 co-ratios. It's just, there's a name change, there's a sign change, it becomes complicated. If I can avoid it, I'm going to. The question initially told me, determine the value of the following without the use of a calculator. So either way, I somehow need to get a special angle here, because that's the only way I'm going to be able to do this without a calculator. So what I can do is I can apply a reduction. Sine of 180 plus 30 gives me 210. 180 plus 30 is 110. Now we look at our reduction. Now please remember that the reduction of sine 180 plus 30, if you go back to your Cartesian plane and your cast diagram, 180 plus 30, or 180 plus, is quadrant 3. That is where tan is positive. So what that actually means is I'm now dealing with a situation where I have got a negative 2 sine 30. And that's all because of the fact that the reduction that I've used of 180 plus means that sine is negative. So this whole expression must now be negative. That's fine though. I can now apply my special angle. So I've got minus 2 times sine 30, which we already know is a half. And minus 2 times a half, I'm just going to write my answer here, is negative 1. So I've still been able to find the value of this expression without a calculator. There was just a fair amount that I needed to do before I got there. As I said earlier, trig is often just algebra in disguise. Everything that I've done here is just algebraic manipulation, obviously except for the reduction formula. But the highest common factor of 2, algebraic roots. It's taking out a highest common factor. That negative, that had to do with the reduction formula. But everything I've done here, you already know how to do. It's now just applying it in the context of the question. And this is what I said at the start of the lesson. There's often different ways that you can deal with things. And there's nothing wrong with doing things differently. But the question is how best to get to where you need to be. Right. So like I said, this is not necessarily the only way to do it. You could definitely use a co-ratio of 270 minus 60. There's nothing wrong with that. You would end up with a negative cos 60. That's fine. There is nothing wrong with that. But again, my preference is to avoid co-ratios when I can. And if I don't have to use a co-ratio, I'm not going to, because I don't want to lose marks in an unnecessary situation by forgetting the sign change or forgetting the name change. That's my advice to you. Take it, don't take it. You have to do what works for you. If I can use a reduction formula, that's what I'm going to do as my first prize. Okay, so if we have a look at a second sort of slightly more complex question, we now have in question D, I have no idea why there's a pen there. It just arrived. Who knows? Just work with it. We have now got cos 15 plus sine 15 squared. Take you back to algebra. What you need to remember here is that anytime you've got a bracket squared, this is saying to you that you're multiplying this bracket twice. You do not distribute that squared in. No. Okay? It is a binomial times a binomial. That's how we have to deal with it. Unfortunately, as it stands right now, cos 15 plus sine 15 is not a double angle identity. I cannot do anything with that at this current point in time. I now need to do this manipulation in order to figure out if there's something I can do. So unfortunately here, in this case, I'm going to have to multiply these two brackets together. Maybe if I could write the bracket. So I'm going to have to multiply the binomial by the binomial in order to get the product. Now, I don't know how many of you learned FOIL or remember FOIL, but that's essentially what we're doing here. You don't have to use FOIL. If you want to, go for it. If you don't want to, fine. What you just need to remember is that this cos 15 has to multiply to both terms in the second bracket and the sine 15 to both terms in the second bracket. As long as you remember to multiply everything in the first bracket with everything in the second bracket, you're fine. So cos 15 times cos 15 gives me cos squared 15. Cos 15 times sine 15 is then just cos 15 sine 15. Sine 15 times cos 15 is exactly the same thing. And you should remember this from your algebra. Your middle terms often being your middle terms when you square a bracket end up being the same, not scare a bracket. And then the sine 15 times sine 15, sine squared 15. Now we've got a fair amount going on here. Okay, we've got 4 terms. We now need to dissect what's actually happening in each of these 4 terms. Go back to your algebra. Once we have multiplied out our binomial times our binomial, we look for like terms. If you have a look in terms of what you've got here, you've got like terms. Cos 15, sine 15, and cos 15, sine 15 are like terms. So we can add those like terms together. So I've got cos squared 15 plus 2 cos 15 sine 15 plus sine squared 15. Right, my question to you is, do you notice anything else that we have going on here that we could maybe apply an identity to, or that we can maybe simplify further? So take a look at the terms you have. Could we do anything else here? You can unmute yourself if you want. You can put it in the chat. What else can I apply here? Lydia, I don't know what that means. What is can? Oh, there we go. Okay, awesome. Good. Okay, so we are looking at a double angle here. Remember, if you go back up to this purple bubble that I've got over here, your double angle for sine is 2 sine A cos A. That's what I've got in this middle term. Just because it's cos and then sine, it doesn't matter. We're multiplying. So we can definitely make this a double angle. So I'm going to bring that to the front, and we can make this a sine double angle. So sine of, actually, let's do this so that we can see what we're doing. No. Pen on the front. Okay, so exactly, we can make this situation a double angle by applying our identity. So this is now going to become sine of 2 times the angle 15. Perfect. What we still have is the cos squared 15 plus the sine squared 15. Does anyone notice anything about this cos squared 15 plus sine squared 15? Then back to the other identities that you already know. Honestly, why would we make it cos? So just remember your identity is cos squared A minus sine squared A. But we do have an identity, and I like where we're thinking about identities. Okay, so guys, just be careful. Like I say, your cos double angle identity is cos squared minus sine squared. Here we've got a cos squared plus sine squared. Remember, we've got an identity that says to us that sine squared theta plus cos squared theta is equal to 1. Exactly, Mashika, thank you. So we've got this identity that we learned in grade 10, grade 11, that says to us, if we're taking the square of sine and cos and adding them together, we get 1. If you're taking the difference of those squares, then it's a cos double angle. But if it's the sum, it's 1. So this whole cos squared 15 plus sine squared 15 is actually just 1. Let's do that. And so now we've got the double angle that we applied, which is just sine of 30 plus 1, because of all the identities that we've been able to apply here. Oops. So sine 30 is a half plus 1, which gives us 1.5. However you choose to write it. I would probably write it as an improper fraction, but any of those forms of the answer, absolutely fine. It doesn't really make a difference. Okay, so guys, what you need to remember are all the identities that you've learned previously. We are introducing what we've introduced, 4 double angle identities, 4 double angle. Yes, 4 double angle identities, 3 for cos, 1 for sine. And then we've also done another 4 compound angle identities. So there's 8 identities that we've looked at over the past 2 weeks. But we still need to remember our tan identity, which is sine over cos, and our squared or Pythagorean identity, which is sine squared plus cos squared, is equal to 1. Right, so let's take these screenshots here, and then you're going to try by yourselves. Like I say, these are the ones that we like to, this is the curveball we throw at you. Okay, it's now something like question C, where you need to be able to manipulate to get your expression to look like the identity you want to use. And this thing's like question D, where we expect you, expect you to be able to apply multiple identities or multiple bits of knowledge that you have about trig to an expression. Okay. Right, so these are the 2 that you have to try. You can pick one, you can do both. I don't particularly mind, it's completely up to you. So it's not right, it's not quite an easy and a hard, but they both follow on from the examples that we've sort of had a look at already. So you've got your double angle formulae here in this purple block. So have a careful look at what they are, and then try either the medium one or the slightly harder one. It's completely up to you. You're welcome to do both if you want. I'm going to give you 3-4 minutes, and then we'll have a look at the answers. Okay, but I really like where our thinking was going with that last one. I'm glad we're thinking about our identities, thinking about how we can use them. While you guys are doing this, just remember to do your quizzes. Obviously, you've got a quiz tonight, so do that first. But if you haven't done any of the quizzes from previous courses, please make sure you do them. I am slowly starting to do memos. As soon as I put the memo up for the quizzes, I am going to obviously close that quiz, so you won't be able to do it anymore. I'm starting with our first course, so the sequences and series. So if you still need to go back and do those, you are still welcome to. But I will eventually close those quizzes once I put the answers up, because then you can just use the answers. Hey guys, let's have a look. So for the medium question, what I need you to remember is that your double angle for cos here is 2 cos squared A minus 1. The order is wrong here. All right. So that's the first thing that we needed to deal with, which is what made this not an easy question. So I first needed to deal with that by taking out this highest common factor of -1 or a negative, it doesn't really matter. And only then, once I'd switched the order to correct order to match my identity, could I then apply the double angle identity. That was a negative cos 45, which is negative root 2 over 2, or negative 1 over root 2. Doesn't matter which one you use. Right, the second one was very, very similar to the question that we just did. It was a binomial times a binomial, so you had to go and deal with that first. Again, what you should have noticed is that the middle term became the sine double angle identity, which is what we ended up with over there. Just bear in mind it had a negative coefficient. And again, what we needed to see was that cos squared 15 plus sine squared 15 gave us that 1. It was the application of the identity again. And so what we now had this time was 1 minus sine 30. And the last one we had sine 30 plus 1. So because of that negative sign, obviously term signs were negative, and we just needed to be mindful of that as we went through.